Welcome to aminacademy.com. In electrical engineering, let us discuss about some detailed types of resistors. Resistors are available in different sizes, shapes and materials. We will discuss all the possible resistors types. Here, resistor is broadly classified as linear resistors and non-linear resistors. In linear resistors, there are fixed resistors and variable resistors. In fixed resistors, there are carbon composition resistor, wire wound resistor, thick film resistors, and thin film resistors. And thick film resistor is further classified as fusible, cement, and metal oxide resistor. And thin film resistor is carbon film and metal film resistors. Now, non-linear resistors are classified as thermistor, photoresistor, that is LDR, light dependent resistor, and varistor resistor and surface mount resistors. This is a broad classification. Then further we will discuss about different types of resistors, that is chart tree is here. Now first, what is linear resistor? Here, look at here, the linear resistors, those resistors which value change with the applied voltage and temperatures are called linear resistors. In other words, the resistor which current value is directly proportional to the applied voltage is known as linear resistors. Look at here, for example. So this is a voltage, this is a current. So linearly varying. That means which current value is directly proportional to the applied voltages. Next, linear resistors. In that further divisions, here non-linear resistance is like here, that is voltage and current is not linearly, maybe like so. This is non-linearly dependent, it's not linear. Fixed resistors, as the name tells everything, fixed resistor is a resistor which has a specific value and cannot change the value of fixed resistors. Types of fixed resistor is carbon composition, wire wound, thin film, thick film resistors. Next is carbon composition resistors. A typical fixed resistor is made from a fixed granulated powdered carbon or graphite, insulation fillers or resin binder. These are made by combination of these things. The ratio of the insulation material determines the actual resistance of the resistor required. Next, the insulation powder, that is a binder made in the shape of the rod, and there are two metal caps on the both ends of the rod. There are two conductor wires here. There are two conductor wires on the both ends of the resistor for easy connectivity to the circuit. And solder it. A plastic coat covers the rods with different color codes printed which denote the resistance value. They are available from 1 ohms to 25 mega ohms, and power rating is quarter watt to 5 watts. These are some carbon composition resistors. These are availability of different sizes. Wire wound resistors. Wire-wound resistor is made from the insulation core or a rod by wrapping around a resistive wire. The resistance wire is generally tungsten, manganese, nickel or nickel, chromium alloy, and the insulating core is made of porcelain, bakelite, press-bound paper or ceramic clay material. The manganese wire wound around resistors are very costly and used with the sensitive test equipments like, for example, Wheatstone bridge. They are available in the range of 2 watts up to 100 watts power rating or more. Here, wire wound resistor is like, here wire is around through the cylinder. Now, inside is like, outside is a mounting brackets and connecting lug here. Wire-wound resistors make lower noise than carbon composition resistors. Their performance is well in overload conditions. They are reliable and flexible and can be used with DC and audio frequency range. Disadvantage of wire-wound resistor is that they are costly and can't be used in high frequency equipment. Applications: wire-wound resistors used where high sensitivity, accurate measurements and balanced current control is required. For example, shunt with ampere meters. For meters, it is measuring meters. It's useful. The film resistors. Basically, all thin film resistors are made of from high-grit ceramic rod and a sensitive resistive material. A very thin conducting material layer overlaid on insulating rod, plate or tube, which is made from high-quality ceramic materials or glass. These are two further types are carbon film resistors and metal film resistors. Here, a carbon film resistors. Carbon film resistors contains on an insulating material rod or core made of high-grade ceramic materials, which is called the substrate. A very thin resistive carbon layer or film overlaid around the rod. These kind of resistors are widely used in electronic circuit because the negligible noise and wide operating range and the stability as compared to solid carbon resistors. Here, look at this. These are color codes to calculate the resistance value, and helixing, insulation, and film and termination leads are given assembly here. Metal film resistors. Metal film resistors are made in construction like carbon film resistors, but the main difference is that there is a metal or a mixture of the metal oxides, nickel, chromium, or mixture of metal and glass, which is called metal glass, which is used as resistive film instead of carbon. Thick film resistors. The production of method of thick film resistors is same like in thin film resistors, but the difference is that there is a thick film instead of thin film for layer of resistive material around. That's why it's called thick film resistors. There are two additional types: metal oxide resistors, ceramic film resistors, and fusible resistors. Metal oxide, by oxidizing a thick film or tin chloride on a heated glass rod substance is the simple method to make a metal oxide resistors. Cermet or oxide resistors, network resistors. In the cermet oxide resistors, the internal area contains on ceramic insulation materials and then a carbon or a metal alloy film or layer wrapped around the resistors and then fix it is in a ceramic metal which is known as cermet or cermet. Next is fusible resistor. These kinds of resistors are same like a wire-wound resistors. When a circuit power rating is increased, then the specified value, what happened? Then is resistor is fused, that is melted. It breaks a or open the circuit. That's why it's called fusible resistors. Fusible resistors, resistors perform double job, means they limit the current as well as it can be used as a fuse also. Some high voltages it fuse. That is current flow is stopped. They use widely in TV sets, amplifiers, and other extensive electronic circuit. Generally, the ohmic value of fusible resistor is less than 10 ohms. Variable resistors. As the name indicates, those resistors which value can be changed through a dial, knob, and screw or manually by a proper method. In this type of resistors, there is a sliding arm which is connected to the shaft, and the value of resistance can be changed by rotating the arm. They are used in the radio receiver or volume control and tone control resistors. Look at here, this next one, potentiometer. Potentiometer is a three-terminal device which is used for controlling the level of voltage in the circuit. The resistance between two external terminal is constant while the third terminal is connected with moving contact wiper, which is variable. The value of resistance can be changed by rotating the wiper which is connected to the control shaft. Here, look at this, the control shaft is here, it's rotated whenever required. So look at this, this is the terminals A, B, C, the resistive material, and rotating wiper shaft is here, carbon track outside. So it's a sectional view, it's a full view here. These are potentiometer construction, how it's looked through. Different types of potentiometer. Resistors are two or three terminal device which is used for the current limiting purpose by hand or manual operation. Resistors are also known as tapped resistors or variable wire-wound resistors. These are resistor constructions. Types of resistors and construction of screw drive resistor here. To make a resistors, the wire wind and nichrome resistance around a ceramic core and then assembled in a protective shell, that is like here. You look at here, resistors work here, inside is a resistive material and sliding contact. Due to that, ohms values are changing. What is the main difference between potentiometer and rheostat? Basically, there is no difference between potentiometer and rheostat. Both are variable resistors. The main difference is the use of circuit operation, for which purpose we use the variable resistor. For example, if we connect a circuit between resistor element terminals, where one terminal in a general end of the resistor element while the other one is sliding contact or wiper as a variable resistors for controlling the circuit current, then it is rheostat. On the other hand, if you do the same as mentioned above for controlling the level of voltage, then this variable resistors would be called the potentiometer. That's all. Next, trimmers. There is an additional screw with potentiometer or variable resistors for better efficiency and operation, and they are known as trimmers. The value of resistance can be changed by changing the position of a screw to rotate by a small screwdriver. That means some adjustment. The trimmer construction is like here. Non-linear resistors. We know that non-linear resistors are those resistors where the current flowing through it does not change according to Ohm's law but change with change in temperature or applied voltages. In addition, if the flowing current through the resistor changes with a change in body temperature, then these kinds of resistors is called thermistors. If the flowing current through a resistor change with the applied voltages, then it is called a varistus, that is VDR, voltage dependent resistors. Following the are the additional types of nonlinear resistors, that is thermistor, varistors, photoresistors or photoconductive cells LDR. Thermistors is a two-terminal device which is very sensitive to temperature. In other words, thermistor is a type of variable resistors which notice the change in temperature. In some equipments, we need to measure change in temperatures. We are using thermistor resistors which have best performances. Thermistors are made from the cobalt, nickel, strontium, and the metal oxides of manganese. The resistance of a thermistor is inversely proportional to the temperature. Resistance increases when temperature decreases as vice versa. Here, these are some thermistors. Here, this is a construction of thermistors. Look as terminal, there's glass and electrode and thermistor chip inside this. Now, varistor. Varistors are voltage dependent resistors, that is VDR, which is used to eliminate the high voltage transients. In other words, the special types of variable resistors used to protect circuit from destructive voltage spikes is called varistors. When voltage increases due to lighting or line faults across a connected sensitive device or system, then it reduces the level of voltages to a secure level. That is, it changes the level of the voltages when something hazardous happen in circuit. Photoresistor or LDR, light dependent resistor, is a resistor with terminal value of resistance changes with a light intensity. In other words, these resistors which resistance value changes with the falling light on their surface is called photoresistor or photoconductive cell or LDR, light dependent resistor. The material which is used to make these kinds of resistor is called photoconductors, or that is example cadmium sulfate, lead sulfate, etc. Look at here. Transparent coating over the surface. When light falls, it changes circuit voltages and resistance. Construction of LDR dependent photoresistors are photoconductive cell. When light falls on the photoconductive cells LDR, that is photoresistors, then there is an increase in the free electron hole pairs due to light energy, which reduces the resistance of semiconductor material. That is, quantity of light energy is inversely proportional to the semiconductor material. It means photoresistors have a negative temperature coefficients. These types of resistors are used in burglar alarm, door openers, flame detector, that is a fire detector, smoke detectors or light meters, light activated relay control circuit, industrials and commercial automatic street light control, and photographic devices and equipments. This is very much useful. Application of resistors. Practically, both types of resistors, fixed and variable, are generally used for the following purposes. For current control and limiting, to change the electrical energy in the form of heat energy, as a shunt in ampere meters, as a multiplier in a voltmeter, to control temperature, to control voltage or drop, for protection purposes like is fusible resistors in laboratories, in home electrical appliances like heaters, iron, immersion rod, etc., widely used in the electronics industries. Thanks for electrical technology org. we have done. Please subscribe our YouTube channel.